This is going to be an acid-base reaction. And this acid-base reaction is between hydrochloric acid, and obviously that's the acid. The base is sodium hydroxide. Hydroxides are always going to be bases. Okay, so this is a nice strong acid and a nice strong base. The base is already in the test tube here, and you might have noticed when I showed you the bottles here that there's really no difference in appearance between the acid and the base. So you might be wondering, well, then how can you tell them apart? How can you tell when this reaction is over or whatever? To do that, we use what is called an indicator, and the indicator, like litmus, we've talked about litmus before. Litmus is an acid-base indicator. Usually that's soaked into paper, and we use that in paper form. For this one, we are going to use a liquid indicator called phenolphthalein. That's kind of a mouthful there, but phenolphthalein is a nice, very common acid-base indicator. And phenolphthalein has the nice property is that in an acid solution, anything that's less than about 8.2, I believe, it is colorless. Okay, it looks just like water. However, if it's in a base, something that has a high pH, then it has a nice bright, well, I'll just let you see. Whoa, nice bright sort of pink color. That was just one drop. That may be all I really need. I'm going to go ahead and put 2 in, but really 1 is probably all I need. There you go. It has a nice bright pink color in it. So that means that when I take this base and I react it with acid, of course, the base is going to be used up, right? It's going to start going away. When we react an acid and a base, remember that an acid contains hydrogen, cation. The base, not all bases, but this base in particular, and a lot of bases contain that hydroxide ion, anion, which is OH. Well, the H from the acid and the OH from the base come together and they form water. And so that leaves the cation from the base, which is sodium hydroxide, and the anion from the acid, in this case chloride from the hydrochloric acid, to form another compound, in this case sodium chloride. Well, that sodium chloride, as you well know, is regular old table salt, and table salt is soluble. So there's no precipitate here per se. We will make water molecules, but the problem is, again, we won't be able to tell when this reaction is over unless we use this indicator. And what will happen is, as the acid reacts all of the base away, eventually this color should go away. Now I put 40 drops of the base in there, and if I've done this correctly, I should be right around 40 drops or so of the acid in order to neutralize it, in order to react it, okay? Oh, it looks like I've already kind of started here. So let me go ahead and add some drops here. 1, 2, 3, 4, oh, they're kind of sliding down here. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 25, 26, 27, 28, 29, 30. Oh boy, I squirted a little bit there. Oh boy. Okay, let's see. It looks like if I just give it a little bit of a shake. Oh, I was wrong. Okay, let me put a little bit more in there. I don't know if you can tell or not, but the color is definitely lighter, and it looks like I'm not even going to shake it. It's going to go away if I just wait on it, and there it goes. Almost like a magic trick, right? So what's kind of fun about this is that if I'm right on the edge here between acid and base, if I just add a couple more drops of the base, it should change back to the pink color, which means if I add just 1 or 2 more drops of the acid, it should change back to clear. Colorless, I should say. Give it a little bit of a shake to speed it up. There it goes. And I can just keep doing this back and forth and back and forth. 1 drop, 2 drops, 3 drops. Oh, that wasn't enough. That's kind of fun too. When it looks like it's going to stay, but it doesn't stay. And then if if I add just a little bit more acid, it goes away again. Okay, so hydrochloric acid reacting with sodium hydroxide, and the products are water and sodium chloride.